Yes. Once you place the brick in this particular bottom place and adjust the top portion to touch down at the top of the brick, the loading will get started. Right. So like this, it has to be placed in such way and through which they are initially start closing the hydraulic load release. Then once they place it like this, and they will start releasing the load from the adjacent portion. So the load applied once, it will show in the dial gauge, right? So it will be having a specific, load what they are telling kg into 1000. So each unit will have a one division. So what they have mentioned, one division is equal to 1000 kg or Newton or something like that. So it will vary with respect to the different equipment. So once the load is started applying, people will start to look for the cracks. So crack formation in the brick. So once the brick is being broken, people will stop the loading process. Then they will note down the maximum load the brick has been withstand without before getting broken. So the load divided by the area, the area, how we can calculate the dimension of the brick we know. So by putting that in the formula load by area, we will be calculating the ultimate stress or bearing stress strength of a brick. So this is how that strength is being measured in the laboratory manner. So this particular why I have wanted to show this to you, the same crushing strength test will be done in most of the construction materials regarding their own purpose where it is going to be used. It's a very common laboratory test, compressive strength testing. So the next one is water absorption. So what is water absorption? Absorption in the sense allowing the water inside the surface or mass of the brick. So since the brick is being manufactured with the natural clay, processed clay, so it will have more number of pores in the outer mass of the brick. So when you immerse the brick into the water, so it will absorb water. So that absorption rate should be within a particular limit. So I hope you remember in the first class brick we have seen that water absorption should not more than be more than 20 percentage. So how they are telling 20 percentage, 25 percentage, like that? Initially you have to weigh, you have to take a brick and you have to weigh, that will be W1 in some kg, and you have to immerse that brick in water bucket for time period of 24 hours. After 24 hours you got to take it out and you got to weigh it again, so that will be W2. Of course W2 will be greater than W1. So that increment should not be more than a specific percentage for a different quality of bricks. So here what they are telling, the water absorption, the increment in the weight should not be more than 20 percentage. For first class brick it should be 15 percentage. In general, the water absorption capacity of a brick should not be more than 20 percentage. In that, for first class brick it should not be go beyond 15 percentage, they are telling. Then efflorescence, right? Bricks should not show white patches when soaked in water for 24 hours and then allowed to dry in a shade place. White patches, where it comes from, white patches are due to the presence of sulfate of calcium or magnesium or potassium. So they keep the masonry permanently in damp and wet conditions. So understand, if you want to know what is the very positive point about a brick is it can withstand the fire in a very high temperature, and naturally since it is made up of a clay, right? In the opposite, what's the negative point about a brick? It is very weak in wet atmosphere. So it can withstand fire, but it cannot withstand the wetness, right? So the wetness, it is being an enemy for your brickwork. So that only in your bathrooms or toilets, the surrounded walls are being tiled to certain height, because the and are often being watered, right? So to protect your wall against the damping and consecutive failure, people are putting tiles. So while the bricks are subjected for that water absorption test, it should not show any white deposits on the surface of the brick. If it has any such deposits, what they are telling, it is because of some calcium sulfate or magnesium sulfate in the raw material of your clay. So what will be the problem? Because of such white deposits, it will be making your brick surface wet continuously. So automatically, as we are told, wetness is the enemy of your brick. So automatically that white patch formation will lead your brick to failure at one point. So that is the efflorescence of brick. So efflorescence is a good or bad? Of course, it's a bad for brick. Then thermal conductivity. Brick should have low thermal conductivity so that buildings built with them are cool in summer and warm in winter. So, of course, in India, 80 percentage of the households are being built with brick masonry. So that is the statistics. So in such a scenario, the brick should have some thermal conductivity. What they are telling, should have low thermal conductivity, which means it should not have high thermal conductivity, so that conveying the whatever the external temperature is available, letting it into the internal temperature, right? Then sound insulation. Oh, in last video we have seen soundness, that is different. So don't confuse soundness with sound insulation. Soundness indicates the good quality of making with respect to the inner mass of the brick. Once you struck with the other brick, it will produce metallic sound. That is soundness. Here, what they are telling, a sound insulation. Of course, we are constructing rooms in series. If you take your classroom, nearby so many classrooms are there, it is being splitted with the help of a single wall, right, from one classroom and another classroom. So in such a scenario, how to make the walls soundproof, right? So the theaters and recording studios, composers, specific offices would be made with the help of sound insulated material. So how bricks performs in sound insulation? Heavier bricks are poor insulators, while lightweight and hollow bricks provide good sound insulation. So here comes the hollow brick, right? So the hollow brick, they are mentioning that it produces more amount of good sound insulation. So hollow bricks, how it will be? So as we have shown in the very first slide, hollow bricks will be looking like this. It may have a different dimension with respect to the configuration and rate, So per brick this much rate. So it will be having more hollowness, or it will be a less hollowness, whatever it may be. So you just assume with the help of this brick, they have made one large wall. So in this side one direction, and in this side one direction. So in between there is a wall made with the help of this hollow brick. So if you are making a sound from in this direction, the sound waves has to penetrate this wall and has to pass through this hollowness continuously, so that to reach the another side of the wall. So since the empty space are available in between adjacent brick edges, the sound waves cannot effectively pass through. Right. So technically speaking, this much decibel, if you are generating in this direction, at the opposite direction, it will be very lesser decibel only will be reaching, because of the absence of medium to carry those sound waves. So that is how people are making sound insulated walls, simply by providing a hollowness in the mass of your brick, right? So that only they are telling solid bricks will be poor sound insulator, while hollow bricks will be a high sound insulator. Why solid bricks are poor in sound insulation? Of course, there is no hollowness. The mass of the brick is available throughout the passage of your sound waves. So the sound waves will pass easily onto them through them, so that another side people can hear the same amount of the sound intensity of sound. So the hollowness provides the sound insulation, right? So then fire resistance, as we have told, brick made up of clay naturally having that fire resistance capacity. Fire resistance of brick is usually good. In fact, the bricks are used to encase steel columns to protect them from fire. Understand, steel column, we will be seeing what is steel column in the upcoming sessions. And what they are telling, to protect the steel columns, certain times people used to encase those steel columns with brick work from production against fire, right? So these and all are properties of bricks. So color, shape, size, texture, soundness, hardness, compressive strength, and water absorption, efflorescence, thermal conductivity, sound insulation, and finally fire resistance. So what are all the uses of bricks? So it can be used as building blocks for lining of ovens, furnaces, and chimneys. So ovens, furnaces, and chimneys are related heating chamber in industry for various purposes, right? So those chambers need to be protected against fire for a longer time period. So it should have some durability. So there people are using brick lining, so that to make them fire resistance for a prolonged period of time. Then for protecting steel column from fire, again the same thing, as aggregates in providing waterproofing to RCC roofs. So understand, aggregate, a term we are seeing here as a newer term. So aggregate in providing waterproof RCC roof. So we will be seeing what it does mean in the second unit, right? While we are talking about the roof components, we will be seeing. Then for pavers, for put footpath and cycle tracks, of course, in the road, along the road, you used to see certain portion of the road or some extended portion will be provided, especially meant for some cyclers or the pedestrians. So those areas, platforms can be made with the help of such bricks. Then for lining, sewer lines. So here again, a newer term we are having, sewer. Sewer is nothing but the underground pipeline which carries wastewater, right? So we will be seeing this in our fourth unit. So in general, wastewater consists of different composition. Finally, the pH of your wastewater, raw wastewater, will be above 7. So above 7 in the sense fully alkaline. So that alkaline condition should be prevented, so that the inner surface of your wastewater carrying pipeline will not be corroded, or erosion will not get happen. So there, the lining of sewer with bricks is being provided, right? So these and all are the uses of bricks. So in bricks, what are the things we have seen? So in bricks, we have started with the introduction, then composition of brick, earth, alumina, silica, lime, and oxides, then classifications of bricks, then properties of bricks, manufacturing of bricks, finally uses of bricks, right?